So in this problem, we need to determine the equation of an ellipse whose focus is at the point 1, 2, with directrix given by 3x plus 4y minus 5 equals to 0, and the eccentricity is 1/2. Let's begin. We'll try to understand the problem graphically first. We begin by considering a vertical straight line which is going to represent the directrix of the ellipse. The equation is given to us, that's 3x plus 4y minus 5 equals to 0. Next, we will consider a straight line that is perpendicular to the directrix line, and on this line, we have the focus. By definition, the line on which the focus lies is referred to as the axis of the ellipse. The coordinates of the focus f, that's given by 1, 2. To find out the equation of the directrix, we are going to consider a point P with coordinates x, y on the plane containing the directrix and the focus, with the condition that if we take the ratio of PF, length PF, to that of the perpendicular length PM, and this ratio is going to be a constant with a value always less than 1. And the constant is referred to as the eccentricity of the ellipse. Here it is given that the eccentricity is 1/2. Now what we'll do? We'll take PF equals to PM. We'll solve this equation to obtain the equation of the ellipse. So here first we will try to determine the length PF. This is a very simple task. Only have to use the distance formula because the coordinates of the endpoints are given to us. We'll take the square root. Underneath the square root, we first take the difference of the x coordinate to get x minus 1. We square this result and then add it to the difference of the y coordinate. So that's y minus 2. And then we're going to square this as well. This will be equals to PM. Now PM is the perpendicular distance of point P from the directrix line. So our goal will be to find out this length. There's a formula that we will be using here. We will consider a point P with the coordinates x1, y1, and we have another straight line with the equation ax plus by plus c equals to 0 expressed in the general form. Drop a perpendicular from point P on the straight line meeting it at M. Then this perpendicular length PM will be defined by the absolute value of ax1 plus by1 plus c divided by the square root of a squared plus b squared. So here a and b are the coefficients of x and y of the straight line. Now in our case, what we'll do, we'll take the absolute value. Inside the absolute value, we'll have to consider a ratio. We'll start with the numerator. So we'll have to take the coefficient of x of the directrix line is 3. 3 gets multiplied to the x coordinate of point P. So that's x. Added to. Next, we'll consider the coefficient of y, which is 4. 4 will get multiplied to the y coordinate of point P. We get 4y. And then we have the constant term added to it. So that's negative 5. Divided by the square root of, so we have to take the sum of the squares of the coefficient of x and y, since they are 3 and 4 respectively. So we'll do 3 squared plus 4 squared. Now what we'll do, we'll square both sides. Squaring both sides, we'll get 4 multiplied to x minus 1 whole squared plus y minus 2 whole squared. This will be equals to, we have 3x plus 4y minus 5 whole squared divided by, so square root of 3 squared plus 4 squared, that's square root of 25. So squaring it gives us 25. Now what we'll do, we will simplify this, and that's going to give us the final expression 90x squared plus 84y squared minus 24xy minus 170x minus 360y plus 475 equals to 0. And this is going to be the required equation of the ellipse whose focus is at the point 1, 2 with directrix and the eccentricity known.